All right, now we're going to look at a few of the problems that you'll have. Now, I may not necessarily solve these completely because it's going to be up to you, but I'll set the stage for you, okay? Another fractional equation. We can't determine what the value of x can be because we don't know what's going to set these denominators off to 0. So let's go and factor each denominator. This x minus 2, x plus 1, minus 3. This needs to factor, probably x minus 3 and x plus 1, negative 3x, that's factored correctly. And then 1 over, this is going to factor to x minus 3, x minus 2. So, the common denominator, the least common denominator is going to be, okay, something that when we multiply everybody by, it's going to cancel out. Okay, we got an x plus 1 that appears in 2 of the 3 groups. The x minus 2 appears in 2 of the 3 groups, and the x minus 3. So our common denominator is x plus 1, x minus 2, and x minus 3. With that as our common denominator, then we can obviously see what the values of the variable cannot be, okay? And we can see here that the x cannot take on a negative 1, x cannot equal 2, and x cannot equal 3. So now let's multiply all expressions by that common denominator. Now I'm not going to write it all out because you should be able to see that common denominator times, okay, the first fraction. The x minus 2, the x plus 1 is going to cancel out, just leaving with x minus 3. Multiplying the 1, that's understood. Minus, okay, in the next we're going to have a 3. We're going to cancel out the x minus 3 and the x plus 1, leaving x minus 2. And in the next, on the other side of the equals, we're just going to have the x minus 3 and x minus 2 cancel out, leaving us with x plus 1. So it leaves us with a pretty manageable equation at that point, and I'm going to let you finish up with it, okay? That is problem number 3 from the worksheet, okay? Let's look at another 1 or 2, and then that should do it, okay? I'm going to look at number 10 from your worksheet. We got 4 over x squared plus 4 plus 5 over x squared plus 5 is equal to 2. Okay? Now, as I said before, we're always determining what x can't equal. Well, there's no value in either one of these denominators that will cause any grief or produce a 0. So therefore, there's really no values to indicate what it cannot be. And I stand corrected up here as I had that interruption with the phone going off, which you heard. This cannot be, cannot be, and cannot be. Okay? So our common denominator, the least common denominator here, x squared plus 4 and x squared plus 5. All right? Multiply by, what happens? This multiplies the first expression. 4 is left to multiply the x squared plus 5. This multiplies the second expression. 5 is left to multiply x squared plus 4. On the other side, we're going to take the product of x squared plus 4 along with x squared plus 5 and that with 2. So you need to multiply that out, distribute that, tie up your terms, solve for x. It goes quadratic. Hopefully it's a factorable quadratic. If not, you can always jump to the quadratic formula. But I'm going to let you finish up with that. Okay? And we'll take a look at one more. Okay? We'll take a look at this number 14. Now, number 14, I've got 3 times the quantity of x plus 1 over x squared minus 7 times 1 plus 1 over x equals 0. Now, ordinarily, we like to think that you could work with those as groups, but they're really not the same. We can identify offhand immediately that x can't equal 0. But really what we have to do is we're just going to have to distribute. Distribute 3x plus 3 over x squared minus 7 minus 7 over x equals 0. Now, x squared is the common denominator. Multiply everybody by x squared. This side by x squared remains as 0. X squared times 3, 3x cubed. Okay, x squared cancel out, plus 3 minus 7x squared. Okay, the x is going to cancel out, minus 7x equals 0. Looks like you should be able to factor that by grouping. Find your solutions, recalling x cannot equal 0. Shouldn't be too bad. Again, we're trying to take these equations, which are fractional in nature, and deal with them by eliminating the denominator. That is, by determining what is the common denominator to all fractions in the equation and multiplying clear through by it. Before we do that, however, or at whatever point we determine what the denominator is, we have to state, okay, the terms that the variable can never assume, okay? And here there were 3, here there were none, primarily because of this situation, and then down here it was just the x equals 0. All right, that's another set of examples for you coming right off the worksheet. So there you go.